Hello, welcome everyone. In this video, I'm going to go over a couple of more properties of logs. Let's start with this particular one. This one says if you take a log of a number with the base being same as that number, it's equal to 1. So I'm going to go ahead and work out some examples and show you how this property holds equal. So if you take a log of 10 with base 10, the property says that it should be equal to 1. So if we simplify this expression right here, we look at 10 and this goes here equals 10, and 10 to the 1 is always equal to 10, so 10 is equal to 10. So whenever we have a log of a number, we're taking it with the same base as the number is, that is always equal to 1. So I'm going to do another one. We have a log of 8 with base 8, that should be also equal to 1. Okay, so if we just evaluate this expression, log of 8 with 8, what is that equal to? Well, 8 raised to, hold on, 8 raised to this unknown must be equal to 8. So what that unknown has to be, it has to be 1. So 8 to the 1 equals 8. So this is true right here. So no matter what the base is, as long as the log of the number that we're taking is same as the base, the answer is always equal to 1. So I'm going to do a few more examples. We have log of 5 with base 5, that is also equal to 1. Let's say log of 3 with base 3 is equal to 1. Log of 2 with base 2 is also equal to 1. Log of 20 with base 20 is also equal to 1. As long as the log of the number and the base are the same, it's always going to hold true, that is equal to 1. Log of 7 with base 7 is equal to 1. Okay, so log of any number with the same base is always equal to 1 right there. Now the next one is if we take the log of 1 with respect to any base, it comes out to be 0. So I'm going to go ahead and show you that. Log of 1 with any base is always equal to 0. So we are taking a log of 1 with, let's say, base 2. What is that equal to? It should be always equal to 0. I'm going to show you how is that possible. So if we take 2 and we put that exponent there is equal to 1. So what do we have to raise this to so we get 1? Well, 2 raised to the 0th power is equal to 1. So any number other than 0 raised to the 0th power is always going to be equal to 1. All right, so this is what this tells you, that log of 1 with respect to any base is going to be equal to 0. So let's say log of 1 with respect to 5 is the base, is also equal to 0, because 5 raised to what power is equal to 1? That is the 0 exponent property. 5 raised to the 0th power is equal to 1. Okay, so let's do a few more examples. We have log of 1 with respect to base 10 is equal to 0 as well, because 10 raised to the 0th power is going to be equal to 1. Okay, this is 1 equals 1, so that's true. Let's do another one. Log of 1 with respect to base 8. That should be equal to 0 as well. So the reason it's 0, 8 raised to what power is equal to 1? Well, 8 to the 0th power is equal to 1. So 1 equals 1. And then we have log of 1 with respect to, with base, let's say 3 is also equal to 0. Okay, 3 raised to what exponent is equal to 1? 3 to the 0 equals 1. So 1 equals 1. All right. One more example. We have log of 1 with base 15 that is also equal to 0. 15 to what power is equal to 1? It's basically 15 to the 0th power equals 1. That's a 0 exponent property. Any number raised to the 0th power is going to be 1. We don't include 0 in that. Okay, you cannot do 0 to the 0 equals 1. So this is what we have for this particular property. If we're taking the log of any 1 with any base is always going to be 0. So very important property to remember. Here we are looking at a couple of other properties. We have log of a b number raised to the nth root or nth power. We're taking the log of that with respect to base. So these two are the same. The log of a number and the base are the same. So to prove that, we know that the power property of the log, the n becomes the multiplier or the coefficient. So basically n goes to the front, and log of b with b. If you look at this right here, log of a number with respect to the same base we already did is equal to 1. So n times 1 equals n. So that's how this property holds right here. For example, if you do log of x cubed with respect to base x is going to be equal to, we take 3 here as a multiplier because it's a power property, log of x with respect to x. So this part right here becomes 1. So 3 times 1 is equal to 3. Similarly, if we have a log of 10 to the 4th with base 10, what is that equal to? That's going to be equal to 4 becomes the multiplier, 10 by 10, and from the previous property we know that this is equal to 1, so it's 4 times 1 equals 4. Let's do one more example. We have a log of x plus 3 to the 2nd power with base x plus 3. So it's just, trying to make it look messy, but it's going to come out to be same too. It becomes 2 times log of x plus 3 with base x plus 3. Okay, so this property is equal to 1. So basically that is equal to 2 times 1, which is equal to 2. All right, now let's take a look at this last one. if you raise, if you have a number and you put the exponent to be log of with the same base with respect to y, is going to be equal to y. Okay, so this one right here, if you have like a 10 raised to the log of some x with base 10, that must be equal to just x. Okay, so if we have like a different expression, let's say 3 raised to the log of some number 5 with base 3, that is equal to 5. So that's another important property that you have to know when we are looking at the logarithm expressions, and we are simplifying them and solving them. I'm going to do one more. If we have 5 raised to the log of 4 with base 5, that is equal to 4. Here we go. So these are a few of the properties that we looked over, and hopefully that helps students learning the logarithm expressions and the properties of the logs. Thank you.